I want to understand it. Okay, so 1.6 solving absolute value equations. And I suppose, I guess, I'll think about it. At the end of class, if we get to it, we can do some of it, which we will get to it. Okay, so solving absolute value equations and absolute value inequalities. So what we've done so far is we have solved linear equations, linear inequalities, and then we have done that's all we solved. So it's going to be now adding in some twist, absolute values, and then you'll see how it goes. Okay, so absolute values are kind of interesting. A lot of us just have it memorized, and if you don't understand what it actually means, and this lesson's confusing unless you really understand what an absolute value actually means. So everybody listen. So the absolute value of 4, a lot of people just think, oh, so it's always positive. So let me explain. These absolute value signs you're going to want to read like this. So these quotation marks actually mean, so these are what you actually think of an absolute value of. So you would say it like this. Tell me all the numbers that are in a distance of 4 units from 0. So here's a number line. I'm going to read that again. When we see the word, the absolute value signs, it means tell me all the numbers that are within a distance of 4 units from 0. So if we look at this, you see how this is within 4 units from 0, everybody? 1, 2, 3, 4, and then this is 4 units from 0 just in the negative direction. It is not a negative distance. It's a positive distance, but it's in the negative direction on the number line. Still 4 units, just this way instead. So the answer that meets this criteria would be anywhere from -4 up to 4 would be a solution here, because that meets the criteria. Because a lot of us just have memorized it. If we have the absolute value of -4, it equals 4. True, yes. Because that just means we have a distance of 4. So even though it's in the negative direction, it's still positive 4 units. Does that make sense, everybody? Cool. Think of it like that, and it's going to make, when we do some harder stuff, a lot easier. Okay, so this is the steps you take to solve an absolute value equation. Take a picture, or you might not even need it, because it's literally just like solving any other type of equation. When we're solving all equations, we isolate whatever we're trying to solve, and then we use algebra to get it along. So first, isolate the absolute value. That means get the absolute value all by itself. You've got to do that before you do anything else. So look, I showed you an example here. The absolute value of x minus 2 minus 3 equals 1. We would first need to add 3 over because we need to isolate the absolute value. Everybody go to step 1. Then you'd say, okay, cool, I have that absolute value isolated. Now the second step is, because this is distance, it says we have a distance in the positive direction and we have a distance in the negative direction. So we're going to write 2 separate equations with both distances. So we have an x minus 2 equal to positive 4 distance and x minus 2 equal to positive 4 distance in the negative direction. So then you just solve individually. So we will then solve for x. Add 2, and we get 2 solutions, but technically we have more than 2. So our solutions are 6 and -2. So anything that's on that interval will meet the criteria. So we would write it like this. From -2 up to 6 work for this absolute value equation. Does everybody see why I wrote -2 first? Because we always write the smallest first. Cool. Okay. Now look, it really works. If you plug in 6 here or here, it'll come out true. So you can check your answers. Look, 6 minus 2 is 4. The absolute value of 4 is 4. 4 minus 3 is 1. And then we plug in 6 here. 6 minus 2 is 4. The absolute value is 4. And it would also work with -2. Yes. You know, I'm not sure. I don't think so. I think you just do this. Okay, let's do another one. Here we go. So solve. So you say, okay, I need to first isolate the absolute value. Done. Then you say, okay, this really means we have a distance of 7. So we have it in the positive 7 direction and the negative 7 direction. So you'll set your 2 equations up. 2x minus 3 equals positive 7, and 2x minus 3 equals -7. Not a negative distance, but a negative, not a negative not a negative distance, but in the negative direction. Just making sure we remember. So we'd add 3, 2x equals 10, divide by 2, so x equals 5. Add 3, 2x equals negative 4. Divide by 2. Therefore, x equals negative 2. So, within a distance of 7 is all of these solutions. Well, it does have a shift though, but I'm just saying. So these are our answers from between negative 2 up to 5, including negative 2 and including 5. Not too bad, right? Okay. Another one. So the absolute value of x, 3x minus 2 plus 3 equals 10. Before you can do anything, before you can even think about it, you have to isolate the absolute value. So we would first subtract 3. So absolute value of 3x minus 2 equals 7. Let's say I had a 7 right here. What would I do? Divide by 7, because that would be attached by a multiplication sign. Okay, cool. So now you say, okay, we have a distance of 7. So 3x minus 2 equals positive 7, and 3x minus 2 equals negative 7. So add 2. Can I do this in my head? Because these are just linear equations. Everybody look. Add 2, divide by 3 is 9, divided by 3 is 3. Okay, good. X equals 3. And then add 2, so that would be 3x equals negative 5. Divided by 3, so negative 5 thirds. So we're going from negative 5 thirds up to 3. Not hard. Okay, so looking at this one will trick people. First, isolate the absolute value. So you'd subtract 7. You have the absolute value of negative x plus 5 equals negative 2. Now here's the thing. You have to remember what technically absolute value means. We have a distance of, looks like negative 2. Can you have a negative distance? No, that wouldn't make sense. So because it's negative, we have to say no solution, because there would be no negative distance. When it was positive, it was okay because it's a distance, and we then give the distance in the positive direction and the negative direction, but that's different than a negative distance. No solution would be our answer here. So, look at this one. What would I do? Subtract 7, and I would get negative 4. No solution. You can't have a distance of a negative. So 2x plus 5 is equal to negative 4, because we subtracted 7 over. Because we have a distance of negative 4. There can't be negative distances. Okay, what about this one? No solution, right? We can't have a distance of negative 2. Don't mess that up on the test. Okay, so let's see what happens when we have a distance of 0. So we would subtract 3 because our first requirement is to get the absolute value along. Okay, equals 0. Now, when you have a distance of 0, that's just at one point. You're starting somewhere and you're not going out at all. So that would be one solution. So we have x plus 1 equals 0. That's the only place. There's distance 0. It's only happening in that one spot. So we would get x equals negative 1. Our answer would just be x equals negative 1. It wouldn't be on an interval because it's just 1 point. So it's 0 distance. Make sense? Yes, because our answer is on negative 1, but that would be 0 distance still on a number line. Our dot would be at negative 1 instead of all of the solutions between this interval and this interval. So only negative 1 is the only thing that makes this a true statement, a distance of 0. Okay. Now, I'm going to point something out. Do you guys remember shifting of functions? Look, it makes sense to look. Okay, this is a shift of, we know this will actually make some of it click for a lot of you. This is a shift of left 1. So if I said to you, distance 0, you'd start here, and that's 0. There's no distance out, right? If it's 0 distance, we're not going to go out at all. Okay, so orange dot is our answer. But then we're shifting left 1. You see how negative 1 makes it the solution? Okay, cool. Okay, so make note of this. This is one people, and I remember it used to confuse me because I would forget the rule here. So far we've been solving and we only had one absolute value, but now when we have two absolute values, you're going to do this step. So I in my notes write when I have two absolute values, because you're going to want to look over this for the test, which is the next time I see you. So this is what you do when you have two absolute values. You're going to understand that it means distance. So remember, we have positive distance, and then we have positive distance and then negative direction. So we have to go through and take care of all four cases technically. So let's start here. So we have a positive distance, and we have a positive distance in the negative direction, true? And then we have a positive distance, and then positive distance in the negative direction. So let's start with the positive, positive. Positive distance, positive distance. So here we go. We're going to do every combination. We would do positive 2x minus 3 equals positive x plus 6. Positive, positive direction. Because what would I do? Okay, so let's say that it would have been this. Positive absolute value of x minus 3 equals 7. Wouldn't we just say 2x minus 3 equals 7 and also 2x minus 3 equals negative 7, everybody? Right? Okay, so now we're going to do the positive and then the negative. That's also a negative distance. So we would say, all right, 2x minus 3 equals, you got to do negative 1 times x plus 6. See how it's negative 7? That's technically negative 1 times 7. Okay, so now we've taken care of the positive, negative. Now let's do the negative and then positive of that. So I'm not erasing it. Get myself those right. Negative, positive. So negative 1 and then 2x minus 3 equals positive x plus 6. And now negative, negative. So you got to put negative 1, 2x minus 3 equals negative 1, x plus 6. And now you just solve each one individually. But yes, and you're going to see something interesting happen right here though, and then, but I didn't want to just teach you, like have you memorize that. I wanted you to understand where it comes from. So what we would do is now solve for x. Subtract x, subtract x. Add 3, add 3. Is anyone mad that I'm like doing two steps at once? Over here, what would I have? An x. That's gone. Equals, over here I get a 9. There's a solution, okay? Let's go to the next one. We would distribute negative 1 in, so we would have 2x minus 3 equals negative x minus 6. So then I'm going to add x and add 3. So now over here I would have 3 x's. That's gone. Equals, that's gone. And we get negative 3. So now divide by 3. So x equals negative 1. I'm going up here to solve. Distribute negative 2x plus 3 equals x plus 6. So I'm going to add 2x, subtract 6. So then over here I would get gone, negative 3 equals 3x, and that's gone. So then doesn't x equal negative 1? Well, we already have that answer, didn't we? Yeah? And then let's go ahead and look at this one. Okay, if I was solving this one, look, a negative 1 and a negative 1. If I'm solving, if I do something to both sides of the equation, isn't it okay? So couldn't I divide both sides by negative 1? And now it's gone, and then isn't it positive? So we've already solved that one. So x equals 9. So what I want you to notice is, yeah, there are two matches. So this one will match up with this one will match up with this one. Yeah, you could go through completely, or you could just say it'll always work out this way. So instead, what I would do is I would just do 2 of them only instead of solving all 4. So you would pick one side. Look, this one, you could do it this way. So do you see I kept this one positive both times? And then just with the other side, make it a positive and then a negative. And it'll take care of everything. I was just showing you that that's really what we're doing, because absolute value means positive and negative. So we did do that. Okay, cool. So let's do that using that rule. So we say, okay, we have an absolute value and an absolute value. So we're going to have an x minus 3 equals positive 2x plus 5. We're also going to have an x minus 3, staying positive, like I said, equals negative 1 times 2x plus 5. And those are going to take care of all the solutions for us. So let's solve. Minus x, subtract 5, subtract 5. So that's gone. That's negative 8 equals x. X equals negative 8. I should have gone back to this. How should I have, I should have wrote my answer like this, from -1 up to 9, my bad. Same thing though. So then right here we're solving, distribute, x minus 3 equals -2x minus 5. Combining my x's. So then over here I would have a 3x, that's gone, equals, that's gone, and we would get -2, right? Divide by 3. So then I have -2/3 is the solution and -8. Did I do something wrong? Okay, cool. So which one's smaller, -8 or -2/3? -8, right, is smaller technically on the number line. Yes, sir? I could have done it wrong though, too. I could have messed up somewhere. So, okay. So if that is truly true, then we'll have a -8 first. We always write the smallest first in the interval notation, up to -2/3. Okay, cool. You guys, okay, awesome. I'm gonna have you now practice some like that. Ready? And go to the homework, and then we'll do some with inequalities in a minute. Because these all have equal signs. It's an equation. Do anything with an equation. Ready, go. ... So everybody, if I said to you, given the set A, don't take notes, set B, this, but you'll take notes in a minute. If I said, do you find A union B? Because remember, this is union. Or if I said, that's the same thing as this, A or B, correct? Okay, so we'd say the set with, isn't this is the friendly one, everybody gets to come to the party, right? So heart gets to come, then smiley face, then 2, 4, 6, 8, 10, and then yeah, 7 and 9. Did I get everything? Okay, cool, that would be our answer. A intersect B, only where they intersect. Okay. Part 8 and 10. Okay, good. We get the picture here. And versus or. This is an and. A and B. It has to be an A and B to go. Okay, cool. So recall with inequalities. So this is an inequality. This is an inequality. It becomes a compound inequality if we then have to merge those answers. So that's what we did last time. We merged the answers together with either and or. Either picky or not picky. So let's look at the solution set. So if I said to you, these are the solutions, so and, so any x value greater than 2. So look, I start at 2, and I go this way. Does everybody see? Any x value greater than 2? But then and at the same time, any x value below 7. So I'm here at 7 and any x value below. You see how I have to stop at those places because that's the only place they intersect. So that would be our solution for and. But what if it was or? So if it was or, we'd be over here at 2 and going that way forever, true? And if it was or, we'd be over here at 7 and going that way forever. So wouldn't it be everything gets to come, so wouldn't it be negative infinity to infinity? And versus or. Okay. So, okay, so now this is when you have to be, it confuses people for some reason. Because it can be tricky if you don't think of absolute value in the correct way. So remember what this means. So write this down in your notes. We have the absolute value of x, which means we have a distance that is 4. Does everybody see? But it's actually saying we have a distance larger than 4 now, instead of equal to 4. We have a distance larger than 4. So if you see greater than, greater, it's always or. Greater is always or. The trick is greater. That's how people remember it. So this one's the friendly one. Either or answer gets to come. And it's going to make sense if you look at it on a number line, what this means. Like a distance larger than 4, it automatically makes it an or statement because of the answer on a number line to make that true. So everybody, look down with me. We have a distance larger than 4 from 0. So right here, do you see how this is a distance 1 from 0? That's not larger than 4, so it wouldn't be in the solution. Does everybody see? 2, 3, now we're at 4. This is a distance at 4. It's not including 4, so I put a parenthesis. Then 5, isn't that a distance greater than 4? 6, 7, 8, and on forever. Now distance larger than 4, that's also in the negative direction. So you see, the distance larger than 4 here would start at -5 and on. Anything past -4. Because it's distance, so a distance larger than 4 would be past this. Like you were saying, how would you say that in a word? So like really our answers here would be negative infinity up to -4. That all fits the criteria. And then 4 to infinity. What? Oh. Oh, yeah. Gotcha, yeah. I don't know. That is, yeah. Yeah, so, well, distance greater than 4. So no matter what, remember, we always start at that, and then either put a bracket or parentheses, including or not. But think about this. Remember, -5 is actually a +5 distance. Doesn't that meet the criteria? It's +5 distance in the negative direction. Does that make sense? That's why, yeah, okay, good. Awesome. It is kind of weird. So look, that's automatically an or statement. This is an answer, all of these, and then or these they meet that criteria. So it automatically works out. Right here, let's look at this one. This one's the distance is below 4. The distance is less than 4. That's always and it actually works out that way if you think about what solutions meet that criteria. So look down here. Any distance below 4. So right here, this would be a distance below 4, a distance below 4, a distance below 4, and a distance below 4. Well, right here's a distance below -4, but it's actually 4, right? A distance below 4, below 4, below 4, below 4. Aren't only those the answers that meet the criteria below 4? Yes, so that's an intersection. So it's stop. That's and. So our solutions are between -4 up to 4 brackets. Nope, that one needs a parenthesis. And our solution here would be negative infinity up to -4, and then 4 to infinity. So, yes. Not including, if it will have an equal sign, yes. Same rules that we've been doing with the others. Because if it was equal to 4, then a distance 4 would be okay. Okay, awesome. So let's solve this one. So it says the absolute value of x plus 3 is greater than 4. So really what all it does is we start here. Don't look at the inside here. You isolate the absolute value. If that was an equal sign, we would isolate the absolute value. That still goes. And you have to remember what this means. Okay, just the absolute value part means we have a distance of greater than 4. A distance larger than 4. Do you guys see how it has nothing to do with the 3? A distance larger than 4. So that's what absolute value means. So look at my thing here. I've drawn it in. Here's my distance larger than 4, 2, and my distance larger than 4 units. Okay. So now look at how we would set this up. We would have an x plus 3 that's greater than 4 to take care of those. We would have an x plus 3 which is less than -4. Isn't it? Less than -4. And now we would just solve each. So subtract 3. Subtract 3. So we would have in our solution set any x values greater than 1. Subtract 3, and this one is, or any x values less than -7, right? Now let's think why this makes sense. Okay, these answers make sense, so it's, here's why. Okay, if there was no shift, here would be our answer. That meets the criteria of distance 4. True? Aren't we shifting left 3 units? Left 3 units would put us at 1, and going that way, shift this left 3 units, and that puts us at -7. So do you see where the answers make sense? Just shift it. Yeah. So our answers would be negative infinity up to -7, since it's an or statement, right? Then union, then we start at, so that's our lowest, negative infinity up to -7, then it skips stuff, and then starts at 1 again, and goes to infinity. So if we were going to write that in a interval notation, or not interval, that's interval notation, set notation, same thing that you did on the last lessons, x values such that x is, how do they have you write it? Like this. Any x values less than -7, or, remember with or they always write it, or x values greater than 1. That's just how you write it, just like last time. Yes. It'll specify. So on your homework, I don't know. Just go with what your homework asks you to do. Okay, let's do another one. Okay, absolute value of 4x minus 3 is greater than or equal to 5. So once again, I have to think about that. We have a distance, ignoring the inside here. We isolate the absolute value, done. We have a distance that's got to be larger than 5. So I've drawn it again, or equal to 5. So starting at 5 this way, those will all be distances larger than 5. No, this is just getting you to see it. It's not necessary. I'll show you in just a second why not. It helps you visualize it, but it's not necessary. The algebra actually will just be, and you'll see. So, and then all of these are distances larger than 5, just in the negative direction. Okay, so you would say, okay, we have 4x minus 3 is greater than or equal to 5, and we also have 4x minus 3 is also less than, you gotta change, do you see how it's split? Less than or equal to negative 5, and then solve each. Add 3, add 3. 4x is greater than or equal to 8, divide by 4. So any x value greater than or equal to 2. Add 3. Did I do something wrong there? Sometimes I'm like thinking ahead as I'm writing. Okay. 4x is less than or equal to negative 2. Divide by 4. Fractions are fine. So we have an x value less than or equal to negative 1/2. So think about it. Since it's or, either or answer gets to come, right? So it's pointing this way. So isn't it going to negative infinity? Negative infinity up to negative 1/2, isn't it? Parenthesis bracket, then it's union. Then we jump over and we have any x value starting at 2 or above. So 2 to infinity. Okay? Pretty okay? Yeah, so what I want you to notice something is some teachers just teach a trick and then, but I wanted you to understand why. So look right here. For those of you that was way beyond your capacity to understand, listen to this. Okay, what do you notice? We took the positive one, right? We took x plus 3, and then we have positive 4. True? If it was an equal sign, wouldn't we have an x plus 3 and a negative 4? Yes? Just like when we were solving that. Then what do they do with the negative one? They switch the sign to the other side. That always is what they do. So look, 4x minus 3 is greater than or equal to 5. You'd start with the original sign and the positive. Then we're doing negative, right? So switch the sign. That will always work. The answers will work out as it is. So let's not have to draw this out each time. Let's just look at this one. So solve this one. It's a greater. It's either or answer gets to come. So we'd first isolate the absolute value. So you'd add 2. We'd have the absolute value of 3x plus 2 is greater than 8. Now you could use the rule or you could think about it and draw a number line. But you can just go like this. 3x plus 2 is larger than 8. True. Distance larger than 8 will work for this. Distance greater than 8. And then we also have a 3x plus 2 is less than negative 8, because that would also meet the criteria. So I switched the sign though, say inequality. Okay, cool, solved now. It's good. That always works. 3x is greater than 6, so x is greater than 2. That's one of true. And then subtract 2, subtract 2. 3x is less than negative 10. Divide by 3, divide by 3. Any x value less than negative 10/3. So either or answer gets to come. I'm going to double underline. So if we were going to put this in interval notation, we write the bottom, the lowest one first. So we're going in. Well, yeah, I guess you're right. It is going clear to negative infinity, right? Because it's not the intersection, it's the either or. So negative infinity up to negative 10/3. Bracket or parenthesis? Parenthesis. Union, then it jumps and it starts at 2 and goes beyond that. So then 2 to infinity. Correct, yeah, 1 would not be a solution. Good question. If I did ask you to draw on a number line, you could, right?
Well, they have it.
They do have you draw on a number line, so yeah, you'll get in practice. Okay, so looking at this one, watch because when people see 0, they freak out with this. So first you have to isolate the absolute value. Absolute value of 2x plus 5 is greater than 0, but you say we have a distance of 0, guys. It's one solution, so we would have 2x plus 5 equals 0. So if it's an inequality and it's 0, there's only going to be one solution. Because there's not a distance greater than, like, so, yeah. Yes, it does? Okay, I was trying to figure out if I was saying it right. So it's similar to if there was an equal sign. 0 just has one answer. So 2x equals negative 5, divide by 2, divide by 2. So that would be our answer. So if you were going to graph it, it would only be a dot. So no, because that is the only spot. So you'd say the set for all x such that x equals negative 5 times. So there's only one solution. Okay, yeah. So now I'm thinking, doesn't that read distance greater than 0? A distance greater than, no, because that would be all real numbers, wouldn't it? All distances that aren't 0 are greater than 0, even if it's positive or negative. But I'm pretty sure that this is the answer. So I'm going to look into that. Do you see why I'm kind of overthinking it now? We have a distance greater than 0, that would be everything. I'm going to look. I swear that this is the answer. Okay, cool. We're going to look into it. Okay, so now let's do less than. Less than is n. Yes. It is 0? Okay. Is that an inequality though? Or is it an equal sign? But is the original problem an inequality? Or an equal sign? Okay, cool. So just treat it like a normal equal sign if it has a 0. Okay, here we go. Now this one's less than, so that's and. So you say we have a distance below 5. So remember that would fit this criteria. From 5 to 5. A distance below 5. So now what would my true statement be? X plus 3 is below 5. And x plus 3 must be greater than negative 5. However, that same trick works that we just did. Look, they take the original, keep the sign the same with the positive, you see? Then they take this and they do the negative, and then they switch the sign to the other side. Bing. It will work out. So here we go, subtract 3, subtract 3. So we have any x values less than 2. And then subtract 3, subtract 3. So then any x values greater than negative 8. This is and, so it's the intersection. So it's between negative 8 up to 2. Negative 8 up to 2, and not including because it's not or equal to. Which makes sense. Look. This was a solution before we shifted it, true? A distance greater or less than 5. These are distances less than 5, everybody. And you're shifting it left 3 units. Left 1, 2, 3. Now it's starting there. Left 1, 2, 3. It's starting at negative 8. Now the solution set just shifted down. Good question. You'll go with what it is, the new one, the newest one that you switch the sign with. Do you see what he's saying? Okay, that's a good question. Okay, another one. Oh, okay, good question. With and, this is how you do it, guys. So just like when we did with and before, the set for x such that isn't x between 2 and negative 8. You put your 2 here, negative 8 here. We'll back here if you need to. It's munching on negative. No, it's munching on x, isn't it? With the negative 8. Munch. So munch. And then it's munching on 2. Like that. With and, they always put it together when they do set notation. I believe. We could write and, I think, too. But this will always be true. Okay, let's do one more. Okay. So looking up here, we'd say the absolute value is less than or equal to 5. So what do we go like this? 2x plus 3 is less than or equal to 5. Then switch it to negative 5 and switch our inequality. And then would we be good? Do you want me to do it? Subtract 3, subtract 3. So you guys see what I'm saying? Switch the inequality sign. Okay. 2x is less than or equal to negative 2. So then x is less than or equal to negative 1. Subtract 3, subtract 3. 2x is greater than or equal to negative 8. Subtract 3, subtract 3, so that's positive 2. Good point, good catch. So this should be positive 1?
Yeah.
Okay, good catch. Divide by 2, divide by 2. So x is greater than or equal to negative 4. Think about it. Starting at negative 4, we're going this way. Starting at 1, we're going this way. It's the intersection, but it's all set up for us. So you'd say, because it's and, so we'll go like this. Negative 4 up to 1. 1 was also included. And then the set for x, such that x is between 1 and negative 4, munching on x, and munching on 1. Yes, sir? Yes. The rules don't change, so yes. Okay, you guys think you got it? What would you do first? You'd subtract 4, wouldn't you? Then you would say, okay, so we're going to have to do the positive 1, switch the inequality and the negative 1. And it's and, so it's the intersection. Yeah. What about this, though? This one tricks people. This is my last one, subtract 3. We have the absolute value of x minus 2 is less than negative 2. A distance of a negative. No solution. Okay, I think you guys are ready to go. The rest of the time is yours to work on 1.6.